My name is Kevin Kelly. This is a companion video for the article entitled Universal Harmony in the Strad Magazine, January 2019. So I'm a violin maker in Boston, and I wrote this article as a kind of introduction to this system of drawing violins that I find really useful. The editors of the Strad magazine thought it might be helpful to have some more explanation about the article for people who are interested, because, as you can imagine, it's very difficult to write an article that's less than 2,000 words that can describe something that's a little complicated and unusual for people. So I agreed to do this video. I hope you'll forgive the fact that it's so informal and unprofessional, and remember that I'm really just a violin maker, not a video producer. But anyway, some people have previewed the article and had a couple of questions and suggested some places that I could offer a little more clarification. So that's what I'm going to try to do here. This is the point of the article that I really want to try to get across, though, is just the idea of using these four tangent circles, tangent meaning they're just touching in one point, to create a framework for drawing a violin. This is the waist, which is the mechanism that I use for controlling the basic framework. So there are two basic parts of the framework that control the shape, and one is the proportions of the circles in the relation to each other, specifically in relation to the lower bout. In this case, these three circles are all 4/5 of the lower bout. And then the waist determines how close or far apart they are. So by pushing these middle two circles closer together or farther apart, it makes the whole body, the beginning of the framework anyway, squatter or longer. I'm going to switch over here to what I call a stick figure drawing, which is a little easier to see since we're going to be using the center of these circles. And this is a typical arrangement. So this is a proportional drawing system, which means that all the measurements come from parts of the drawing that already exist, starting with the lower bout radius. So we have a lower bout radius. Those circles, the red ones, are 4/5 of that, and the waist in this drawing is half that. These are not set in stone, but these are pretty basic proportions, and once you learn how to use the system, you can change them any way you like. We divide the lower bout diameter by 3 to give us the radius for these, what I call the second turns. Or sometimes people call it the hips, or the shoulders of the fiddle. It's the continuation of the upper and lower bouts. In this case, the upper bout second turns are the same radius circle as the lower bout. That's a fairly typical look for a Cremonese fiddle, especially pre-Stradivari and pre-Del Gesù. We connect these center of the second turns in the lower bout and the other centers of the upper bout and C bout circles to give us our points lines. We take 5/6 of the C bout circle to get our points circle. The intersection of those points, we draw lines across the form. Then we find our block locating points. In this case, in the upper bout, it's the second turns. In the lower bout, we divide the radius by 3 and take one of those thirds to give us our block layout lines. Now, using the upper bout circle and the lower bout circle and those block layout lines, at the intersections of those, we are going to draw another 2 lines across the form, which leaves us with these 4 lines, which we then use to further finish drawing the shapes of the upper and lower corner blocks. It's a fairly simple operation. We take the radius, use the distance between those two lines as a radius, and in the lower bout here in this drawing, the lower corners, the radius describes both sides of the corner block. In the upper corner, it describes the outside of the corner block, and then because the C-bout turn is very much tighter there, we'll take a fraction of that upper bout circle. In this case, it's 4/5. And that's our basic stick figure drawing. I didn't include the end blocks in this drawing, but this is the Geometry Engine drawing, Harry Merson's Geometry Engine that I mentioned in the article, with all those relationships coded into them. This is a drawing program that simply draws lines and circles. And this is the drawing compared to the Andre Amati 1560 or so in the National Music Museum in South Dakota, of the earliest fiddles in existence. One thing that people mentioned upon reading this article for the first time is this is a different idea. In this drawing, so this is the length of the mold, or the body length, is often the very first thing that people consider when they're designing an instrument now. And that's not how this system works. The body length is more or less a byproduct of the design, and there's lots of factors that can alter it. So if you're concerned about the body length, which we all are, what I do is I do a drawing, a proportional drawing like this, and then measure it and see how it comes out, and then you scale the drawing when it comes time to make a template for a mold to the correct size. So that's an important difference between this and the way people normally draw fiddles. This is an entirely proportional system that's outside of any other measuring system, and you have to measure the things when you're done. This Geometry Engine program will measure whatever you tell it to, too, so that makes it easier for me. Now I want to talk a little bit about going from this drawing to the grand pattern. So what we're doing here is we're going to change the C-bout circles and right now and leave everything else the same. So those green lines there represent the waist, which we're not going to change, but we're going to replace those C-bout circles with some smaller ones. In this case, they're 2/3 of the lower bout instead of 4/5. And you can see from this drawing that these 4 circles are no longer tangent, so we will correct that. Now what we just did is we made a shorter body, which when we scale it back up to the normal body length means that the whole body is wider. So we proportionally increased the width of the instrument by using those smaller C-bout circles. I'm going to put my point circles in and layout lines. This is the same scheme as the previous drawing, which gives us these locations for the points of the corners. Now you can't see from this drawing, but that gives you quite a small C-bout, and it looks awkward and very tight. So we're going to do a trick here. We're going to stick the previous C-bout circles back in there, which of course are not tangent anymore because they're much bigger. But by using that circle for the center of the points, laying out the points, it makes the C-bout open up and makes it much more like the previous iteration. So it doesn't look quite so different. And there's different functions for these C-bout centers, which of course I'm not getting into in this article, but hopefully I'll be able to do some more writing soon that explains more about that. But there are 6 separate functions that the centers of the C-bouts perform. There's the 4-circle layout, which is the basic framework. It's to use it to lay out the points line. We use it to lay out the block layout lines. It's the center of the points circle. It's the center of the drawn C-bout, as I say, which ends up in the actual shape of the instrument. And it's also used to lay out the F-holes, the sound holes. Those are 6 separate functions, and in the basic Andrea Amati version, one point serves all 6 functions, but they don't have to. You can mix and match various centers as things get more complicated. Not sure if I should have thrown that in here in this description or not, but just so you know, this is a fairly simple drawing. There's the Geometry Engine version of the same compared to the CT scan of a grand pattern. The Brookings, in the Library of Congress from 1654. About 80 some years after the first one. Another question that people brought up after reading the article is about the golden section, and some people have a question about whether it was a practical measurement that would be used by a Renaissance craftsperson, and of course it is. This is how you derive golden section. It's a square. You divide the square in half. You take a diagonal of half the square, add that to one side of the square, and that's the golden section relationship. Once you have that relationship, you can then make a tool, a proportional divider or a sector or some other drawing tool that you can make with a compass and a straight edge at a workbench, and have a tool that does this for you. No math involved, really. All right, let's do this last illustration, which is the Del Gesù. So we'll go back to an Andrea Amati stick figure. And now in this case, we are going to do something slightly different. In the previous change, we kept the waist the same and changed the C-bout circle. In this one, we're going to keep the C-bout circle the same and change the waist. So this is the arrangement that this drawing has. It's half the lower bout, and we're going to the lines there for the illustrate the waist, just to show that we're about to change that. We're going to substitute this, which is 2/3 of the upper bout. We push that waist wider. Now, again, these circles are no longer tangent, so we will fix that. And again, the drawing just became compacted, became shorter. So when you scale the thing back up, the whole body's going to be wider. These are the same Geometry Engine kind of, it's just an algorithm for this 4-circle drawing. But I'm going to make one change here, one more change rather, which is we're going to move that center of the points line from the center of the upper bout to the center of the second turn. Just going to move that over. And there's the Geometry Engine drawing of that. Now, I thought it might be interesting to take a look under the hood at the geometry, and this is a piece of the Geometry Engine code for these drawings, and I wanted to show you the difference between what I just did in that last slide. This is the that one value there describes the point that the line is supposed to go through. So that's the Amati arrangement on the right and the Del Gesù arrangement on the left. And I changed that one value in the code, which moves the line, which changes the intersection points, which changes the radius and the locations of the corners. So all that stuff is done automatically by the computer in the program by just changing that one value. So we may find a way to make that a little more accessible for people in the future, but this is how I draw violins right now. There's the Geometry Engine drawing. There's compared to this Del Gesù violin from 1741. Okay, and that's basically covers everything that we talked about in the article, plus some. I hope it wasn't more confusing than illustrative. But anyway, thanks for listening. Bye.